Welcome to a video on factorial notation. So factorial notation. So you might have seen this symbol on your calculator. It's got the exclamation mark, which is the symbol that represents factorial. What it does is it's the multiplication or the positive or the whole numbers, so the natural whole numbers, from n to 1. So therefore, if we were saying 4 factorial, it'd be 4 times 3 times 2 times 1. And you could do that either on your calculator by pressing in 4 times 3 times 2 times 1, or you could do 4 factorial and it would get you 24. Note, n factorial is from n multiplied all the way down to 1. So n being the first term multiplied by the next term after, n is n minus 1, multiplied by the next term after that, which is n minus 2, times, etc., all the way down to 4 times 3 times 2 times 1. That's the n factorial. And an important thing to note, 0 factorial is equal to 1. And you could put that on your calculator to check. So here's some examples that we're going to do. And we're going to do them without the calculator, and then you can check them with the calculator. Well, really only the first and the third one you can do with your calculator, because the rest you need to understand factorial notation. So the first one, 12 factorial over 10 factorial. So we're going to write, for each of these, we're going to expand each of the larger factorials into its multiples down to the lower factorial. So we'll start with the 12 factorial over 10 factorial. So the larger factorial is 12 factorial. So that's 12 times 11 times, and then it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, or times 10 factorial. And now you can see that obviously we can simplify by cancelling out the 10 factorial on the top with the bottom, and you're left with 12 times 11, or 132. So what about when we have n's in our equation? So once again, start with the largest one. So n plus 1 factorial is the largest. So n plus 1, the next term after that, 1 less than it is n, times 1 less than that is n minus 1, and that's the bottom. So now it's n minus 1 factorial, because everything after that is a repetition of what's on the bottom. So the n minus 1 factorials cancel from the top and the bottom, and you're left with n plus 1 times n, and if you expand that, you get n squared plus n. The next one, so expand the largest. So 8 factorial is bigger than 7 factorial. So 8 factorial is 8 times 7 factorial. Now we know when we add fractions, we need to get a common denominator. So let's do that. So I have to times the first term by 8, top and bottom, so that the denominators are the same. So on the top I get 8 plus 1, and on the bottom I get 8 factorial. So I get 9 over 8 factorial. And for our final example, we've got 1 over n minus 1 factorial minus 2 over n plus 1 factorial. So expand the largest factorial, which is the second fraction. And so you get n plus 1 times n minus 1 factorial. So now we need a common denominator. So the first fraction is missing n plus 1 n times n. So we're going to times the top and bottom by that. So when you times the top and bottom, you get n plus 1 times n. So on the top, you get n squared plus n. On the bottom, you get n plus 1 times n, or n plus 1 factorial. And of course, we can factorize the numerator when you get n squared plus n minus 2 to become n plus 2 n minus 1. Thank you.